Welcome to qnawire.
So we're given all this information, and ultimately we want to maximize profit. So to maximize profit, we need to consider the different constraints that we have. So in this case, we have that each hot dog yields a profit of 0.2. So it's going to be our profit equals 0.20. We'll call X the hot dog, or X1 hot dog, and then plus 0.10 X2. And that's going to be our bun profit. So ultimately, the constraints that we have is, since there are 200 pounds used for making the hot dogs, 200 pounds per week, we see that 0.1, since each hot dog bun requires 0.1 pounds of flour, we see 0.1 times x2, the number of buns has to be less than or equal to 200. And then we have 800 pounds of pork. Each hot dog requires 1/4 of that. So we're going to have 0.25 x1, so that's the amount of hot dogs, is less than or equal to 800, because 800 is the max pounds of pork. So then, in addition, we know that the labor force is 5 employees working full time, and then it's going to be 3 hours for each hot dog, and 3 minutes for each hot dog, and then 2 minutes for each bun. So it's going to be 3x1 plus 2x2 is less than or equal to, and we know that needs to be 12,000 hours based on the 40-hour work week. So, and then lastly, we know that we can't make negative hot dogs or negative buns, so that's going to be all greater than or equal to 0. And then based on those observations, we can plot all of these inequalities and see which region, what is our feasible region, and then based on that, see the different points in our feasible region and then maximize the profit. We can't do that because we're not graphing, but once we have this set up, the linear program is actually very simple.